So are you able to see my screen?
No, sir.
Okay. Now it's coming.
Yes, sir. Now it is visible.
Okay, thank you. So, we discussed in the last class about the how to design the pressure pipes as gravity mains, and we have discussed about different formulas which are mainly used to determine the head loss and as well as the velocity. So, flow velocity and head loss. So these are the two parameters, and we covered in the last class. Now the immediate components of distribution network is pumps, and in this particular section there might be several type of pumps, but what we are going to discuss here is pumps for lifting water. And so that is the main objective. In our case, though pump can basically lift up any sort of fluid to the higher elevation or at higher pressure, but in this case our main objective is to lift up the water. So that is why pumps for lifting water is what we are going to study. So there are several situations, where we may need the, we may need the help of or assistance of the pump for our distribution network. So there might be several situations, just let me write here one by one. So first one is lift at the source, right? So if you see, to lift the water at the source when the water cannot flow by the gravity into the mains, such as the case where there is a low-level surface sources and the groundwater sources both are at low level, and your ground is at the higher level. So you need a pump to lift it from the source to the distribution channel, right? Next is lift of water at the treatment plant. So lift at the treatment plant itself. So if sufficient natural slope is not available, which can cause the gravitational flow between different units within the treatment plants, we need to take the aid of the additional pumps by which we can apply the pressure to reach the water from one particular treatment component to the next one. There might be another one situation where you know lift after the treatment. So in this case, once water is treated completely, and then again you are unable to get that gravitational gradient by which you can have enough gravitational flow. And in those kind of situation, again to force the water in the distributing mains, directly or through service reservoir, we need a certain type of pump to work over here. And number four, in the distribution system. Now you might have heard of booster pump. So that in this case, the main purpose is if water is moving through the gravitational force, and after a certain point of time, since the quantity of water is less, because there might be several consumption point before that point, and in those cases we may need extra pump to create additional pressure to reach to the farthest consumption point. And if you may have a two stories building at the farthest consumption point, and the water in usual pressure is not getting lifted off, so in those cases a boosted pump can sort out this issue. So there are several situations, I have discussed. So where you should have pump, or where usually we take help of different type of pumps. Now, if we talk about the classification of pumps, so this here things become so interesting, So we are going to talk about them now. Let's talk about the type of pump. Types. So, depending upon different categories, we can classify pumps into three major categories. One is based on mechanical principle of operation. So we would say principle of operation. So in this case, we'll have all sorts of uh, displacement pumps, which we will be discussing maybe in detail. Displacement pump. Next is, most of you have heard, centrifugal pump. Next is airlift pumps. And next is miscellaneous pump. So in miscellaneous pump, usually we talk about impulse pumps. So there might be different type of pumps, and depending upon which one is required, we can install. So we say that miscellaneous pumps. Miscellaneous pump. Now, if we see the second type, so number 2, we can type based on power required. Based on power required. So here also you might have heard of some. First one is steam engine pumps. Fine. Next is which one is quite common in our country, that is diesel engine pumps. Fine. The sophisticated one is electrically driven pump or electrically operated pump. So third one is electrically operated pumps. Fine. So if you see, usually three different type of pumps you can see, And apart from that, we have gasoline pumps also these days, So another one is getting popularity, that is gasoline pump. So these are the different type of pump, depending upon what kind of energy it is going to utilize. So now we'll be talking about pump classification based on different type of service. So let's go to the next page here. Again, I'll change the so number 3 is type of service in which pumps are going to be involved. So here we have low lift pump, usually low lift pumps are used before treatment plant. Fine. High lift pump. So high lift pumps are utilized usually after the treatment. So when you send it to the when you send it to the distribution channel. After the treatment. Fine. Number 3, we have deep well pumps. So deep well pumps. So mostly we say sometimes these, and in submersible pumps. So those are deep well pumps. Number 4, we have booster pumps. Now, what is the purpose or what is the kind of service which we render from booster pumps have been mentioned before. And number 5 is standby pumps. Fine. So these are the different type of pumps which we are going to talk about. Now, generally high lift pumps are attached after the treatment plant, and low lift pumps are attached before the treatment plant. In usual practice, since the pressure exertion which is required after the treatment is much higher compared to the before treatment. So that's the main reason of putting it in this way. Now with this, we'll move and we'll talk about those pumps which are commonly used. So the type of pumps and their suitability. This is what we are going to use now, because in practice we see these kind of pumps, and we will be during our practice in the field, we'll come across such kind of pumps. So the first one is displacement pumps. So different type of examples can be given of displacement pumps, such as reciprocating pumps, rotary, chain gear wheel pump, and windmill. So these are the different type of displacement pumps. Now suitability, this type of pumps are suitable for moderate heads and small discharges suitable for fire protection, water supply of individual houses. Now, next one is velocity pumps. So in this case, we have centrifugal pumps, deep well turbine pumps, jet pumps. So these types of pumps are used widely in water supply schemes containing sand, silt, etc. So, if you see, these kind of pumps are much more robust and it can handle more amount of discharge. So that is the reason, for the overall water supply scheme, velocity pumps are widely used. Next are buoyancy pumps. So one such example of buoyancy pump is airlifting pump, and airlifting pump is generally adopted for pumping of water from deep wells to a lift of about 60 meter, and it can contain mud, silt, and debris. Fine. And next is impulse pump. So I told that impulse pump is one sort of miscellaneous pumps which we discussed. So impulse pumps, so one such type of impulse pump is hydraulic ram, and this is used for small water supply projects to lift the water for a height of about 30 meter or so. So if we want to lift it for a lower height, we can use the impulse pump. So there are detailed discussion of, if you see, there are detailed discussion on centrifugal pump, especially because in most of the time centrifugal pump is used. And as well as, if we go back to the previous slide, the centrifugal pumps and reciprocating pumps, these two pumps are used widely, and that is why their overall principal components are also mentioned. However, as per the syllabus, I could not include them, but if you wish to study them, you can go through any standard textbook, so you will be able to know better about the centrifugal pumps and all other pumps which we usually used in the practice. So with this, we'll move to factors affecting selection of a particular type of pump.
Sir, which type of pumps are used widely?
See, this from this table only you will be able to understand. You see, we say that centrifugal pumps and deep well pumps, turbine pumps, and jet pumps, they are the pumps which are widely used in the supply scheme. So in most of the cases, you can see a combination of centrifugal pumps and reciprocating pumps, which are being used. See, when we say water supply scheme, so it has several components. So in lower pressure or in low discharge situation, you can use a reciprocating pump. So that is the most common in that category. On the other hand, when we talk about velocity pumps, mostly centrifugal pumps and jet pumps and deep well pumps, these are the pumps which are conventionally used, and it is used in larger scale, and that is what even in mentioned in the suitability column. You can go through that. Fine.
Yes, sir.
Okay. So now we'll be talking about factors affecting selection of pumps. So obviously, what are the, based on our discussion till now, we can point out this different type of pumps. So capacity of pump is very important, whether this is a low lift pump or high lift pump, how much amount of discharge it is. It can articulate those things are need to be discussed before selecting a particular type of pumps. Suppose if you are talking about if you are talking about full water supply scheme, and if you are planning a displacement pump like reciprocating pumps or rotary pumps, then it won't make any sense, because you need to go for the velocity pumps, which is much more robust. On the other hand, importance of water supply scheme, so that is again for which kind of purposes or in which kind of applications you are going to construct water supply schemes. Now, if it is for the entire city, or if entire municipality, or if the entire total population where it is huge, in those cases you have to have pumps, you have to have standby pumps, you have to have a robust pump which has more discharge. So this is also a very important point. Initial cost of pumping arrangements, so that is another one big aspect. There might be a situation where there are two different type of pumps which are satisfying the conditions. However, you need to see that which one is having the initial low initial cost of pumping, and that pump should be included for the project. Then another one is maintenance cost, since these all are consisting of some sort of engine where you need some fuels or energy. So there would be a component which is maintenance, and this maintenance aspect sometimes play a very vital role in overall judgment of the pumps and its suitability. So that is why maintenance cost is very significant to consider before uh, selecting a particular type of pump. Now, space requirement for locating a pump is also important, as I mentioned in the beginning, where you want to install the pump. If the pump is installed before the treatment, if you want to install a pump at the surface, and if you want to install a pump just after the treatment plant into the distribution system, or to reach the water or to maintain the pressure at the farthest end of the consumption point, so where exactly your pump will be located, depending upon that, you have to choose a particular type of pump. Next is number of units required. So how many pumps you are going to install? If you install 3 4 small pump, or if you want to install a bigger pump or a more powerful pump, one, and how much would be the difference in the maintenance, operation, and as well as overall cost, those things would be considered. Total lift of water which is required to run water supply scheme, that is also important. So we need to see how much amount of water is going to be lifted up, and finally quantity of water to be pumped. So in the entire water supply scheme where you are planning to install the pump, so through that pump, how much overall quantity of water, maybe daily, yeah, monthly and yearly, are going to be pumped, that is also very important aspect while choosing a particular type of pump. And now, there are few points which we need to consider before important points which we need to consider for selecting selecting a different type of pumps. So we are going to talk about that. First one is so basic data regarding the water availability, like diameter, depth of the well, depth of the water table, seasonal variation of the water table, drawdown duration of the pumping, and safe yield are to be collected accurately before you want to select a particular type of pump. And there may be several variables of different specifications and choices available, and th- that is where the optimization becomes very important for an engineer. And because see, this is a part which can influence significantly to the overall cost of the project. So that is why we discuss about different points so significantly, because it has very substantial influence in the overall cost. So the first one is capacity and efficiency. So the pump should have that capacity required and in the optimum efficiency. Second one is lift. So suction head from the water level to the pump level is very important, and how much amount of lift is required is the key point to choose basic category of a pump. Next is head. So it is also called as delivery head, which is required. So generally the total head, suction and delivery head, should meet all possible situations with respect to the head. So in different season you may have variation in the overall head, and how your pump is going to handle that is a big question. And before you select a particular type of pump, you need to ensure that the pump which you are selecting would be able to manage this fluctuation in the overall head. Next is reliability. This reliability can be again related with the maintenance of the pump, and at the same time how much is the overall life in terms of hours for a particular pump, because they are going to be used relentlessly, whenever it is required throughout the year. So that is why reliability is a big question. How many days, like if you might have seen, let's say give an example. So if suppose you are buying a car A, another one person is buying car B, and we see that car A can run up to 5 lakh kilometers, and car B, its engine can run up to 10 lakhs kilometers. So in that case, if we have to comment on the reliability of those two, among those two cars, we will say that car B has much more reliability of that engine, and that is why it should be preferred, provided we have a efficient costing of that car B. So accordingly, reliability is a big aspect while choosing one particular type of pump. Now, initial cost, the cost of the pump and its installation, where you are going to install, how much area is required, whether you need any staff, how many valves are required to operate those things, should be minimum as less as possible. So if you can work on the initial cost, then that will significantly affect the overall cost of the project. Power requirements, which we have discussed extensively, and then maintenance. So maintenance, though we have mentioned separately, it can be included in the initial cost. Sorry, in the reliability aspect also. However, though it's for any reliable pump or any reliable engine for that matter, you need some maintenance, and periodic maintenance often enhances the reliability aspect of any motor or any engine or any pumps, and that is why maintenance should be taken into account, and the cost of the maintenance should be lesser, and all those parts and all the different components should be available in the market. So whenever you have a problem or whenever you are required to change a particular parts of that pump, it should be easily available in the market, so that you can go and buy it and change it, and your system would run without having any interruption for a longer time period. So these are the different points which needs to be kept in the mind before choosing a particular type of pump. So now we'll be discussing about the total head of the pump, and this is very important. So the total head of the pump, if we say, it consists of three different head. One is the suction lift, which can be denoted as HS, the delivery head, that is the HD, and the head loss due to friction, entrance and exit in the rising main, so that is HL. So these are the three components which we usually discuss while talking about the pump. Now, the work done by the pump for lifting cubic meter per second of water discharge by a head of H, we can say that gamma W into Q into capital H, that is the kilonewton meter per second or joule per second or watt. That is the unit for that. So the water horsepower of the pump can be calculated from there. And if you see here, the gamma W, all of you know, that is the unit. Q is the discharge in meter cube per second, discharge which has to be pumped. And now if we talk about the water horsepower, so that is basically gamma W QH by 0.735. Since 1 horsepower equals to 735 watt equals to 0.735 kilowatt. So that is why we are basically dividing with 0.75. And if you want to calculate the brake horsepower, which is usually the way we calculate the capacity of the pump. So let's say the efficiency of the pump set is zeta, then the brake horsepower of the pump can be given as WHP by eta. So WHP has already been defined, so that is gamma W into Q into H by eta into 0.735. Now this is the brake horsepower, and this is the way we can calculate the brake horsepower for any pump. Fine. So just to remember, again I am telling that there are three components which are our main concern. One is the suction lift, another one is the delivery head, another one the head loss due to the friction, entrance and exit in the rising main. So H equals to HS plus HD plus HL, and that is what, based on that, we can calculate the brake horsepower. Fine. So there are few problems, and you may get several problems from this part, as well as the when we discussed about the design of the pressure mains or pressure conduits in the previous class. So these two are very important part as far as numerical problems are concerned. So you should practice them, and if time permits, I will discuss few problems in the class itself, or I'll give you some assignment. If you practice them, then things will be much more clear to you people. Fine. So now we'll be talking about the location of pumping station. So the location of pumping station is primarily governed by the location of the place from where it is to receive the water. Fine. So that, depending upon that, the pumping station has to be constructed, and also by the location of the place where it is to supply that water. So one important part is from where it is collecting, another important part is where it is supplying, and depending upon that, pumping station can be constructed. So the various points which we should keep in our mind while selecting a suitable site are given below, and are being discussed in this particular slide. So I'll take one by one, and I'll explain it to you if it is required. So the site should be away from all sorts of contamination or pollution. So this part we discussed in different way while talking about intake. Fine. So different type of intake structures. When we are discussing, we wanted to construct intake structures in a position in the water body where the contamination or the chances of contamination is minimal. Now same philosophy goes for the pumping station. If you want to construct a pumping station in the source, you need to take care of the contamination and pollution part. And after assessing the all the points where you can construct the pumping station, the points which has the minimum probability of on source contamination or pollution should be chosen for constructing this component. This site should be above the highest flood level of the water river, obviously, because if your pump is submerged, then the pump will be out of service, and it will be damaged completely beyond repair, and it will be a huge loss as far as money is concerned, as far as the cost of the project is concerned. That is why always you should ensure that the pumping station is located above the highest flood level in that particular water body or in that particular river. It should also be so selected that its future growth and expansion is easily possible. So if you want to install more pumping station which is attached to the existing pumping station, so that provision is required and you need to plan accordingly. So only seeing one particular aspect would not be decisive. The places or the points which satisfies all the points which we are discussing here should be the most apt for constructing a pumping station. In case of any rivers, the site for the pumping station should be such that the pumping machinery is able to draw sufficient water so as to meet the peak demand during the busiest hour of the day. It's very important. In order to achieve this, the dry weather flow in the river, the likely changes in the river course, these aspects must be properly studied and considered, and then only. So the main idea is you need to get uninterrupted water during its dry season and during the busiest hour. Now to do that, we'll have to do all the different study associated with the dry weather flow, the changes in the river course, and the variation in the water because of the variation in the season. So those things are really important. Next one is possibilities of fire hazard should also be considered while selecting a site for pumping stations. Again, we will be dealing with fuel, we'll be dealing with maybe electrical conduits. At the same time, we'll have that expensive pump motor. So we need to minimize the possibility of getting damage from the fire hazard or fire accident. So that is also a very important part to consider while selecting a particular location for constructing the pumping station. And the final one is the proximity of the site to the railways from where the coal can be quickly made available for producing power may also have to be considered. Though these particular points are quite obsolete, but we need to take care that one fact, that is the conducive for producing power. Now if we say conducive for producing power, that means even if we want to install a diesel operated or an electrically operated or a gasoline operated pump. So then, it has to be, the pump station should be easily accessible for any vehicle, so that it can go there and it can dump the fuel whatever is required for periodically. So though we don't talk about railways through which we can get the coal, but however, to run all those different type of pumps, you need some amount of energy resources, and for that we need to have access to those sites, and which and that is the reason we have to take care of this particular point. So with this, we'll stop today. In the next class, we'll be discussing about the distribution system. Right? Though pipe is another one important component, so that I'll discuss after the distribution components. So with this, we'll stop today.